Students, in this class, we are going to see the various definitions of an antenna. Up to now, everybody is having their own doubt that how these electromagnetic waves are produced. To produce these electromagnetic waves, antenna is much more essential element. So, in this class, let me define what is an antenna. So, antenna is a wire. Basically, antenna is a wire. But remember, friends, alone the wire cannot radiate the information. That means antenna should be having an excitation at one end. Suppose, for example, if you take an antenna, this is a wire. If you excite at one end, that means if you are giving the excitation at the one end, then only the radiation of information takes place. So the basic definition is very simple. Antenna is a wire which is excited at one end. That is much more important. So excitation must be there. So it should be excited at one end. Then only it becomes an antenna. So excitation is much more essential. And the second one is I would like to tell you the definition of antenna is here. Suppose for example, if you are taking a communication block diagram, you are having three components. One is transmitter and other one is the receiver. In between you are having a channel. This is a channel. And remember friends, without an antenna, you cannot radiate the information to the surroundings. So you require an antenna. So if you are taking the most famous and simplest antenna, which is nothing but your Unguided antenna as a transmitting antenna. This is a transmitting antenna. And one more antenna if you take here, this is a receiving antenna. So this is also Unguided antenna. In between these two antennas, you are having a channel. That channel may be wired or wireless, but in order to send the information to the large distances, then definitely you have to go for the wireless communication. So wireless channel will be there. So that wireless communication is possible whenever you are sending the information in terms of electromagnetic waves. So where the antenna will be placed in the communication? The antenna is acting like an interface between the transmitter and free space. Free space means it is a channel. This is called free space. And it is also acting like an interface between the free space and the receiver. That means it is acting like an interface between your transmitter and free space and receiver. And the antenna is the only device which can understand the language of electromagnetic waves. Nobody knows. That's why in the communications you are having the placement of this antenna between the transmitter and the free space and the receiver. If you want to establish a communication between the 2 points, doubtless you are going to have an antenna. Antenna is a must for communications. And for example, if you are taking a cell and inside the cell also you are having an antenna, that antenna may be different. That is called a patch antenna. It is a microstrip antenna which occupies very less space inside the cell. That's the reason we are getting the cells with a small size nowadays. And now, it is a antenna can be defined as the third definition I am telling you. It is a metallic device. Metallic device, and metallic device means it may be a rod or wire. It may be a rod or a wire. This is a metallic device. And this is a metallic device. It is a metallic structure which is converting your electrical energy into electromagnetic energy and electromagnetic energy into electrical energy. That means it is converting one energy into another energy. That's why I can tell the next definition, that is your antenna is a transducer. What do you mean by transducer? Transducer means which can convert one energy form into another form. And one more definition I would like to tell you. It is a sensor. What do you mean by sensor? It senses something. It is a sensor of electromagnetic waves. Wherever the electromagnetic waves are coming here in the free space, it can sense it. And basically it is a metallic device. So it may be in the form of a rod or it may be in the form of a wire. So that's why the very first definition I am telling you, antenna is a wire which is excited at one end. And now let us focus on this figure. So if you take this figure, and I would like to tell you the exact definition of an antenna, which is actually given by this IEEE society. IEEE society is actually giving the standard definitions for all the devices in electronics. It is nothing but Institution of Electrical and Electronics Engineering, that is IEEE. As for this, I would like to define what is an antenna now. So if you see here, this is the source, and the source is having a generator. Generator means it is dynamic fields are actually produced by the generator, or otherwise time varying fields. And already you know, in the last classes, if you are taking a static charge here, some field will be around like this. This is electric field. And if you are making a current carrying conductor, it is a steady current is here, the fields will be circular like this magnetic field. So these fields are actually static, they are not moving from point to point. But here, there is a possibility of sending the information from one place to the other place for the time varying fields. That is the reason I am telling you, the source is nothing but a time varying fields. So whenever it is actually producing these time varying fields, now if you see here, from this point to this point, it is a transmission line. So what do you mean by this transmission line? Transmission line is a device which can transmit the information from one place to the other place. So from here to here, it is a transmission line. And through it is a conducting line, it is a conducting wire mechanism. Now from this to this, actually these fields are moving from one place to the other place. Now you see, these are the positive one, and these are the positive here, and once again here this is the positive, and this will be negative like this. This is the negative. That means the energy is oscillating on this transmission line like this. So what is basically a transmission line? Transmission line is nothing but a guided structure. It is guiding this electrical energy from this place to this place. It is guiding. Actually, these conductors are guiding this energy in this direction. So what are the different types of transmission lines that are possible here? You can go for either a coaxial line, coaxial cables you can use, or otherwise even waveguides also you can utilize it. You know, in the future classes I can tell you why the waveguides are preferred. Why the waveguides comes into the picture? They are meant for actually guiding the maximum power on these lines. Your coaxial lines and ordinary parallel wire transmission lines can handle small powers. Whenever the power is more for a signal, then the people are going for these waveguides. So whatever it may be, it is a transmission line, it is a physical mechanism guiding this energy from this place to this place. So that's why there is an oscillating of energy in this direction. Just to understand this concept, I am telling with the three lines. These are the lines of force. These are the electric field lines. They are always originating from positive to negative, negative to positive. But as this is having positive and negative cycle variation alternating fields, it is also alternating like this. Now whenever it is coming like this, from this point to this point, from this point onwards, you are having a widening of the transmission line like this. So whenever you are widening the transmission line like this, energy is escaping from this. This energy is actually escaping from these lines to the surroundings. Now let me see the definition of an antenna first. So what is an antenna? This is an antenna. A antenna is nothing but an interface between your transmission line and your free space. Free space means you can say that it is unguided media. Unguided, there is no guidance at all. Here it is an unguided media, but whereas the transmission lines is your guided media. Now what is the definition of the antenna? Antenna is a structure. Antenna is a metallic structure, or otherwise antenna is like an interface, which antenna is a matching device between your guided media and unguided media. So it is a matching device between the guiding structure and unguided structure. That is the important definition of an antenna. And one more definition I would like to tell you, it is also the sixth one I can say, it is a matching device also. So what do you mean by this matching device? What it matches the impedance of the devices. Now let me say the communication block diagram once again here. It is a transmitter and it is a receiver. Transmitter is having some output impedance. and your channel is having your free space impedance, that is 377 ohms. 377 ohms. So this is actually a transmitter, and the antenna has to match the impedance of the output of the transmitter as well as 377. Then only maximum communication is possible. You know very well, my dear friends, what is maximum power transfer theorem? Maximum power will be transferred from source to the load whenever the load impedance is the complex conjugate of the source impedance. Of course, if they are the resistances, load resistance must be equal to the source resistance. Then only maximum communication is possible. Even antenna is also like this. What is an antenna? The antenna is actually matching the impedances levels of your guided structure and unguided structure. Then only the maximum communication is taking place, maximum radiation is taking place. So, friends, in order to transmit maximum information to this, then some metallic structures or some other structures are required to transmit the maximum information from this guided medium to unguided medium. What is unguided? It is nothing but a free space. So, free space is nothing but an unguided structure. So, that's the reason the antenna is playing a crucial role in transmitting the information from one place to the other place. So, this way you have to understand the concept of your antenna. And I would like to give a small example. For example, I am a teacher. I have to understand what exactly in the textbooks. And then after understanding all these concepts, I have to tell all those concepts to the students. That means I am acting like an interface between two different protocols. One is the textbook level and the second one is the students. So, in order to match these two protocols, one interface is needed. That interface, that sensor is nothing but an antenna. So, teacher is an antenna who is acting like a matching device between your textbook as well as your students. So, if the teacher is absent, the students also can understand the information from the, but it requires lot of time to understand this because the radiation is very, very small. Here also, without this also some radiation is taking place. But in order to radiate the maximum information to the surroundings, it is requiring most of the time. Maximum time it is actually required to get this information to transmit from this place to this place. So that's why I can tell you finally, antenna is a sensor. Antenna is a sensor of electromagnetic waves. Antenna is an interface between the two different protocols, two different matching devices. And antenna is a matching device. And very first basic definition is, antenna is a metallic rod, metallic device. It may be in the rod form or it may be in the wire form. So that's why the basic antennas are nothing but the wire antennas. What are the different wire antennas? I can say various wire antennas I can say here. Wire antennas, with a simple wire you can have different types of antennas. Out of this, the very first one is, you can say dipole. Your dipole is a wire antenna. Your loop antenna, how the dipole comes here. Now at this moment I cannot tell you how the idea comes to the scientists about this antenna. How the idea comes to the scientists. Now if you take this transmission line here, and basically if you take a transmission line subject here, once again I would like to tell you, this is the transmission line. This is the transmission line. One side you are sending the information, this is the source, and you are having a load here. This is, let me say, ZL, or otherwise if it is a purely resistive, I can say this is RL. RL is the load. Whenever you are sending the information from the source to the load, in the transmission lines I told you, you are having an incident wave like this. You are sending the information like this. And you can say that the wave which is reflecting back, it is called reflected wave like this. So I can say that this is the incident voltage and this is the reflected voltage, incident and reflective. So now I would like to define the most important parameter, that is reflection coefficient K. What is K? K is equal to VR by VI, reflected by incident. Now let me tell you what are the possible values of the K. K may be equal to 0. Where K is equal to 0, what does it mean? K is equal to 0 means VR is equal to 0. Nothing is reflected back. Excellent, excellent matching device. Suppose if K is equal to 1, I can say that VR is equal to VI. That means whatever I am sending, I am getting back like this. That is k is equal to 1. But practically, I can say k will be in between 0 and 1 like this. This is the reflection coefficient. Now, I would like to tell you with a small example. Whatever I am sending the information to the students is incident voltage. Whatever they are sending to me is reflected voltage. If the interface is excellent, if the impedance matching is excellent, if the students are actually tuned to me perfectly, then nothing will be reflected back to me. That means VR is equal to 0. So, if I see the k is equal to 0 in this class, I will be an excellent teacher because everybody is understanding my lecture. Suppose nobody is hearing, nobody is enjoying my lecture, then everything I am getting back, then k is equal to 1. It is the worst class I can say. So, it is after all a business between the source and the load. If the source and the load are perfectly matched, then nothing will be reflected back. So, that is why you are having either k is equal to 0 or k is equal to 1 extreme values. But practically, my dear friends, every student can understand at least a small amount of knowledge. And the second one is they cannot understand fully. That is the reason k will be always in between 0 and 1. Now, I would like to tell you how the scientists got the idea of this antenna. Now, if you take this antenna here, and here it is a open circuited. It is a open circuited. It is a open circuited structure. For a open circuited structure, energy is incidenting here. Positive to negative, the energy is incidenting like this. So, this is called incident voltage. But because of the mismatching, it is reflected back like this. It is reflecting back like this. So, something you are getting in the backward direction also because of the impedance mismatching. Suppose if RL is equal to infinity, that means if it is open circuited here, if it is open circuited, then definitely k value must be equal to 1. That means whatever you are sending, entire thing will be reflected back here. But there is a magic I would like to tell you, my dear friends. Actually, you have to expect the value of k is equal to 1. But the people got k is equal to only 0.9. That means 0.1 is missing. 10% energy is mixing. Then they understood very clearly, I am sending 100% energy in the forward direction. As it is open circuited, entire energy has to be reflected back. But unfortunately, we are getting only 90%. But what is happening for this 10%? They got the idea. Something is happening. 10% is actually leaving this. And what is happening to this 10% energy? Thus, that 10% energy is actually radiating to the free space like this. Then the people got the idea. There is a mechanism which is unknown to us, that there is a transmission of energy from wires to the surroundings also. Then the people got the idea. Yes, without any physical mechanism, happily we can send the information to the free space. And what to do? They started the research. After starting the research, then they have actually tried in different directions. So actually after this opening, after this flaring of this one, they flared this much and they have done like this. Then they got 30% of energy missing. That means 30% of energy is actually going to the surroundings. Again, still they are doing like this. Then they have done like this. Then it may be around 40 and 50 and 60. Like that, after doing different types of experiments here, maximum energy is actually escaped to the surroundings. And finally, friends, they found that whenever this limb is at an angle of 90 degrees like this, at an angle of 90 degrees like this, then the maximum energy is actually escaped from these transmission lines. Then everybody is happy. Without any wiring mechanism, whenever you are sending this energy from the source, and whenever the limbs are at an angle of 90 degrees like this, maximum energy is actually escaping from this. Then finally, what they done is, then they got this. This is the structure they have got like this. This is the structure. And here, they have given maximum information to this. This is the information they have given like this. Now, this limb is at an angle of 90 degrees, and this limb is also at an angle of 90 degrees. Then, if you take this limb length, L is equal to lambda by 2, this is lambda by 2, then it becomes an half wave dipole because the length is half wave. It is a dipole because it is having positive polarity and negative polarity. And finally, in the future classes we can say the radiation is a maximum from this dipole. How this radiation actually, how this half wave dipole is formed? This dipole is formed from the concept of your transmission lines only. From the transmission lines, I have seen you the reflection coefficient. Just on the basis of the reflection coefficient, I concluded that something is missing from this. And that missing factor has enhanced by doing your research methods here. Then immediately, whenever the limbs are at an angle of 90 degrees like this, maximum information is escaped from this surroundings here. And finally, they concluded that maximum radiation takes place at an angle of 90 degrees to this axis, that is in the normal direction. This is at an angle of 90 degrees to this. So if you are taking this dipole, this is the axis of the dipole, at an angle of 90 degrees to this axis, maximum information is actually escaping from this. So in this way, you are actually radiating the maximum information in the broadside direction like this. So all these things will be discussed in detail in your future classes. So finally, whatever it may be, if you take this antenna, the antenna is actually acting like an interface, or otherwise it is a matching device, or otherwise it is acting like a perfect matching device in between guided structure and unguided structure. Guiding means physical medium, unguided means free space. What is the free space here? It is 377 ohms. And it may be something like you are having a characteristic impedance Z0 here for a transmission line. This impedance is, and this impedance will be different. Whenever the two impedances are different, maximum power transfer theorem cannot be achieved here. So if you want to get the maximum power transfer from source to the load, here the load is free space, source is this generator. If you want to send the maximum information from this to this, the only way is you have to do something in between. That something is nothing but the role of an antenna. So antenna is a metallic rod or wire which is excited at one end. I am exciting here and I am just radiating the information in this direction. After doing so much of research project here, finally I concluded the radiation is maximum whenever the limbs are at an angle of 90 degrees, and which is the basis of the formation of your half wave dipole. So if you take this half wave dipole, the radiation is maximum at an angle of 90 degrees to this, and there is no radiation along the axis of this dipole. And if the length is set to lambda by 2, it becomes an half wave dipole. So that's why basically it is just an introduction for our antennas, and we have defined an antenna as a wire excited at one end. It is a sensor of electromagnetic waves, and it is a metallic structure which is actually acting like a matching device between transmitter and free space and receiver. And it is a transducer which can convert the energy from electrical energy to electromagnetic, or electromagnetic to electrical energy. I hope you understood the role of an antenna and various definitions of an antenna in this class. And in the next class, we are going to see the radiation mechanism of an antenna. Okay, thank you.